Okay, so good morning everyone, Senan this side, and in this video we are going to solve this find the longest substring containing vowels in even counts. And this problem is a bit difficult to solve because you won't be able to get the exact idea initially. So I'll try to make this as simple as possible. So let's look at what exactly the question is stating. Given the string s, return the size of the longest substring. So size, so the return type is an integer containing each vowel an even number of times, that is a, e, I, o, u must appear an even number of times. Okay, so I need to find the substring which has the all the elements of the vowels in even numbers, and yep, that even does contain the length 0 as well. So s only contains lowercase and length is pretty big. So clearly if you try to generate all substrings and verify this condition, then that would be more than n square, order of n square, and this is something for not the order of n square. It's somewhere about big of n or big of n log n. Okay, so in this case you see BC, which is of size 6, and since all the vowels appear exactly 0 times and 0 is an even number, so this is a valid answer. Now we get what the problem is exactly asking. You see this, this in this case is the answer. And why? Because E, I, N, O appear 2 times, and E-I-N-O appears 2 times, and A-N-U appear 0 times. This is also a valid string. So first approach could be to think of solving this through a sliding window approach. And sliding window won't exactly work because okay, I'll tell you why this won't work in my notebook. So let's say this is your string, or let me draw this properly. So this is your string, and let's say you are having a sliding window and you got an, let's say, a at this position. Right now you're seeing an a, and the length of a in this is odd. So you see that you saw an a which has an odd length in this window. So what that means is this cannot be a valid substring. So what you would do is you would take this left and shift it one place to the right, let's say with this. So this would be your new substring. But there is a case where somewhere down the line, if you had considered this a, you would have gotten an a somewhere here, which would actually nullify this odd number of a's to even a's, and this could actually possibly be our answer, right? So if you are at a position where you saw an a or any vowel, so you don't exactly know that if you have to shift the left pointer or you have to shift the right pointer, or what you could have done is try both ways like recursion, and that would be some sort of exponential. I'm not looking at that solution. I'm just saying that either if you try all the possible cases, it won't be a sliding window problem, and if you try, that would be recursion. Obviously you could memorize that stuff and improve that, but what I'm trying to say is, given an a, you cannot determine that should we move the left pointer or the right pointer, so sliding window is not possible. Now a few more things. The question is asking even vowels. So what I'm doing is I'm breaking the solution into pieces and I'm explaining you those pieces individually, and in the end we'll just collect all of them, right? So let's say if we have to count, let's say we have a string a b c, a b e, and we have to count the number of vowels in this case, right? So how do you count the vowels? You'll traverse this string, right? And you'll say you see a, so you'll mark a as 2 and e as 1. Maybe you could use a map, you could use an array, whatever you want. I'm just trying to build up the idea. Now the question is asking even number of vowels. It's not saying 2, 4, 0, 6, 8, nothing like that, right? It has to be even. So what I could do is, given the string itself, what I could say is, are all the vowels of even length? So what I could do, I could traverse this string and say a has 2 elements, so that means it's true. A is of even length. Similarly, if you see e has a single occurrence, so e is not number of occurrences of e is not even. Similarly, I, O, U would be correct, because they have 0 length. So if you see, if you just have to keep track of the number of elements, the even number of occurrence of vowels, you can just make them 0 and 1, which will allow you to keep track the number of elements, right? If there are even or not. This is one thing. Now what you could do is you could use a vector of 5 elements, right? That will allow you to store 5 vowels, or you could use a vector of 26 elements and use only these 5 places in the vector to store a, e, I, o, u, the number of occurrences in that. Maybe it could be even odd, denoted using 0 and 1. And yep, that is one thing. Finally, if you see this, we discussed how do you keep track of the number of vowels. Then since it is asking for even vowels, so what I do is I just store a single integer of 0 or 1, or a boolean value 0 or 1, to keep track of the number of occurrences. Fine. Now let's say you have this array of 5 elements, right? Rather than storing this in a vector of size 5, what I could do is I just write this as this: a, I, o, u, and write the occurrences like this. So this is 1, this is 0, this is 1, 1, 1. Okay, and so we have this number, right? So you could store this as a single integer, right? You could store this information in a single integer. That is what we are trying to go for, and that is why this is a bit mask problem, right? So since the occurrence is either yes or no, so what would happen is you will just store this single integer and that will do your job. Now let's look at this example. Maybe not exactly an example. Let's say after this you saw an I. So what you would do is you'll update this number to 11001. So this 0 for I denotes that we have even number of i's, right? So what I'll do is I'll now discuss the idea of the problem. This is a string of, let's say this is the word that we are given is this, and now I'll traverse from left to right, and at every letter that I see I'll take this integer, maybe count, and what I'll do is I'll just update this number. So initially my count would be 0, so 0 0 0 0 0. So what I'll do is if I see an A, I'll make this 1. If I see an A, I'll make this 1. If I again see an A, I'll make this 0. Similarly, if I see E, I'll make this 1. If I again see E, I'll make this 0. And if I again see E, I'll make this 1, and so on. A, E, I, O, U. So whenever I see an A, I, or U, I flip the corresponding bit of this count variable, right? So you have to keep this in mind, that you have to flip the bit. So while flipping, you are keeping track of the odd or even, right? If it is so, in this case, the idea would be a bit different. So I used 100, right? 10111. What I'll do is I'll denote 0 for even number of occurrence and 1 for odd number of occurrences, which is totally opposite of what I did here. So this would be 0, so the 1 would be 0 0 and 0. Okay, so whenever I see an element, I'll just flip that particular bit. Keep track of the state of the word that we have seen till now. Now one more thing you have to understand is that you have 26 letters in the English alphabet, and one integer is of size 32 bits, the standard 4 bytes, right? So this is 32 bits. So what you could do is you could store all these 26 letters in this integer, but you'll only update the vowels. So rather than having A, E, I, O, U, just one after the other, what you'll do is A, B, C, D, E. So whenever you see an A, you'll update this bit. Whenever you'll see an E, you'll update this bit, and so on, and you won't touch any of the middle character. So so as I showed you, this is of size 5, but this won't be of size 5. This would be of size 26, actually 32, in which you're only using 26, and out of 26 only 5 bits are those which you'll actually do the update on. So now let's do a simple dry run of any test case. So I'll show you this example of LeetCode is great. So this is your right, this is your given string, and what you have to find is the maximum string which has even number of vowels. Now keep this in mind, 0 is always a solution, always a solution, right? Anyways, 0 is always the solution. Now what I'll do is whenever I see a state, I'll store that state at what integer I found that. So let me mark the location 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. Hope I did not make any mistake. So initially my count is, let's say, 0 0 0 0 0 for A I O U. So I'll mark it as this position, and this is found at, let's say, index -1. Why -1? We'll see, because we'll see why I'll mark it as index -1. So this is the starting position. So this index is 0. This index is -1 because we are starting before that. Before any even seeing this string of integers, I know this is the starting position at index -1. That means before we even start reading the string. So I'll see an L, right? I see an L, so I don't do anything. I see an E now at index 1. So what would be 0 0 0 1 0 at, this is at the position 1. Now again I go to E, and what I see is when I do the flip again go back to this initial string. So what I would do is, since if I do the bit flip, it would actually go back to this initial state. So what I'll do is I'll take this and I'll take this value and I'll do the subtraction with this index. So that would give me, so let's use a max length, which is current index is 2 minus this state, because when you see this E, you again go back to this state, right? Comma. So what I'll do is I'll just take this value and do the subtraction. This is what? This is 3. So see, you got a string of size 3, this one, and this is a valid substring given the constraints. It may not be the maximum length, but it is a possible string. Okay, so now what I do is I just move one step ahead. I see an T, no change. I'll see a C, no change. But when I see an O is at index 4. So I'll just update from this. I'll come to here, which will be 0 1 0 0 0, and this is at index 4. Yep, one mistake that I did here in this explanation is when I saw this T, what I'll do is I'll see this value is 3, and I'll see at position T we have this orientation. So what I'll do is I'll say 3 minus 1 give me the length 4. So when I go to C, right, when I go to C, I'll again update this max length to 5, right? I'm updating this length as we go on and on, not only at the position where we find a change, but every time we move one step ahead, we try to update the max length, right? Now what we are going to do is whenever we saw this O, and this O would be this condition, and looking at the string ahead, there is no O after this, right? And if you see, actually what you have to do is do the same operation on this string. DE is great, and what in the end you would find is this is actually the maximum length you could actually find, because again I is a single element, E is a single element, A is single element in this case. So these are of odd length, so you won't actually find an answer. This is the idea. Let's actually look at the code, and that would allow me to explain you better. So find the longest substring. So what I do is I take an unordered map which will keep track of the current state and the index that I found. I keep track of maximum length, and I keep a track of whatever the bit mask is. Basically this is the count that I'm talking about. So initially I'll say map of 0 is -1, and for I0, I is less than s dot size. That means I'm traversing through all the elements of the string. What I do is I say that if it is A, E, I, O or U, what you do is you flip that bit mask, the bit at this, in this bit mask variable. If you see an A, you change the bit, you flip the bit at the location A. Similarly, if you see E, I or O or U, you change that particular bit, or you flip that bit. Now what I do is I'll say if mpp.count, that means either you could use the find operation in this or count operation in this. So count would return 1 if this exists in the map, or it would return 0 if it is not. So it's better than using a find. Find has a longer syntax. So mpp.count, if I found this bit mask, that means I've been at a state similar to before. So what I do is I update the max length to max of max length, or I minus this bit mask, right? So this would give you the maximum length at each iteration, if you've seen this state before as well. Okay, so otherwise you'll update this location in the bitmask with the current index, and that would actually return you the max length. Now I know the dry run was too small because I did not want to do a lot of computation, but I would really suggest you to do for this substring, and you would actually realize that this actually works. So clearly this is accepted and test results are also accepted. So hope I was able to explain this to you. The idea is of using bit masking and to store the occurrence or the evenness. Occurrence is even or odd of a character or a vowel is stored in a single integer. So all the thing that you actually need to understand is this statement itself. So yep, that was the whole video, and I'll see you in the next one.